In this video, I'm going to talk about generators. If you've ever wondered how windmills generate electricity, then now you will finally learn it. Generators. What is it? How does it work? So here's the concept behind your generators. It's really an application of Faraday's Law. You've got an EMF induced in a loop because the magnetic flux through it is changing. Let's look at this picture here. We have a loop, and something is causing it to rotate, right? If you think of your windmill, think the wind is causing the rotation of that loop. There's an external field here, so as this loop is rotating, the flux through it is changing. Sometimes there's a lot of field going through it, so if this loop is vertical, there's a lot of magnetic field going through it, but when the loop is horizontal, right, if the field lines are this way, but if your loop is horizontal, that loop is not catching any of the field lines. There's no field going through it. So the flux through the loop is changing. This induces an EMF in the circuit according to Faraday's Law. So the basic idea behind a generator is that it's going to convert mechanical energy, you need something to rotate this, into electrical energy. If an EMF is going to be induced, then you hook it up to a current, and then it can run whatever device that you need. So we're not going to show the derivation, but it turns out that if you use Faraday's Law, you can figure out that the EMF induced is going to be given by this expression. N is the number of loops, B is the external field, A is the area of the loop, omega is the angular frequency of the loop. So we haven't seen that one in a while, but we learned a little bit about it in Physics 1. It's equal to 2 pi f, where f is the frequency. So angular frequency is talking about how many cycles that it's rotating through per second, but instead of cycles, you're converting it to an angle since every cycle has 2 pi radians. So sine of the angular frequency times time. So make sure that when you're using this equation that your calculator is in radian mode, because the unit for angular frequency is radians per second. So the EMF induced when you have a generator varies like a sine wave. Sometimes you have a lot of EMF induced, sometimes you have no EMF induced, and it keeps cycling due to the rotation of that loop in that magnetic field. If you want to know what's the maximum EMF that can be induced, you just make the sine function cross out to 1 because that makes it a maximum, and we're left with NBA omega. So when you want to use this equation, well, if it says that you have a generator, then you can definitely use this equation to find the EMF induced. Or if you just visualize what we saw in the previous slide, whenever you have that loop that is rotating in that external field, then this will be the EMF induced. Let's take a look at this example. A circular coil, you are given the area right here, is placed in a magnetic field. What's going to be the induced EMF if the coil is rotated at 20 radians per second? For part A, about an axis that is aligned with the magnetic field. So even though we have a loop that's rotating in an external field, don't rush into using the equation that we just learned. You've got to make sure that it's applicable. Let's draw a picture here. We don't know which way the field is going, but let's just assume it's going up. It doesn't matter which way it's going. It says that the loop is rotated about an axis aligned with the field. So if you have this loop here, and you draw an axis that is also vertical like the magnetic field, and you're rotating it this way. So what you're visualizing here, this is a vertical loop, and it's rotating about this vertical axis. So sometimes when it's rotating, you see that full loop. Sometimes you're just going to see a little sliver of the loop as this side is rotating towards you, and this side is rotating away from you, just so you visualize. So is the flux through this loop changing? The answer is no. Remember to think of magnetic flux as a measure of how many magnetic field lines are going through that loop. Well, if this loop is vertical, it's never catching any of these field lines, right? You have a vertical piece of paper, you have these lines just passing right in front of it or right behind it. Even as it's rotating, it's never catching any lines. In order to catch some lines, it'd have to be like this so that the field lines can go through that loop. It'd have to be horizontal, not vertical. So the answer to this question is actually 0. There is no induced EMF because the flux through the loop is not changing. Let's take a look at part B though. Now the loop is rotated about an axis perpendicular to the field. So if you draw your field going up, and now you can draw your loop, and we can draw it just like before. We can draw it vertical, but now the axis is horizontal, right? The axis is perpendicular to the field here. So if you rotate it, now you can see that, okay, when it's vertical like this, it doesn't have any field going through it, but as it's rotating, now let's say that this end here is coming towards us, and this end here is moving away from us. So at some point, this loop is going to be horizontal, and then it will have a whole bunch of lines going through it. So when the loop is rotating this way with this axis, then the flux through it is changing. So now we can use the fact that the induced EMF is going to be N, B, A, omega, sine, omega t. So let's see what we can plug in here. N is the number of turns. There's only one. N is equal to 1. It just is a coil. B is the magnetic field, 0.05 teslas. A is the area. Let's go ahead and convert that to meters squared. So we have to divide by 100 squared. Remember your conversions. 25 centimeters squared. You're trying to convert that to meters squared. You have 100 squared centimeters squared in your meter squared, right? If the unit is squared, you square the prefix as well. So you can see that you've got to divide 25 by 100 squared to get meters squared. So we're going to get 0.0025 meters squared. Then omega is our angular frequency, 20 radians per second. And we're not given time, right? So the way this equation works is if you know at what time, then you can find the exact number for how much EMF is induced at that time. But in this case, we're going to have to leave our answer as a function of time. So when we plug in NBA omega, when we plug that in, we're going to get 2.5 times 10 to the negative 3. So that's these 4 terms right here. And then sine, and then our angular frequency is 20 radians per second. And time has to stay as a variable. So this is our final answer. I know it doesn't look great, but basically it's saying that we're going to have this many volts induced as a function of time. So now if you know what time that you want, you can plug it in, and then you can actually get a number for this. So that is all for this section. I hope that you enjoyed it.